Hello folks, this is Dr. Young, and in this video we're going to talk about mixtures, specifically the difference between a heterogeneous mixture and a homogeneous. So before, right, we were doing our sort of different types of matter, right? We talked about elements, compounds, and mixtures, but now we're just going to come back and kind of explain a little bit more about mixtures, just like in future videos we'll come back and explain a little bit more about compounds. So remember I had an example similar to this in the last video, so I'll just quickly go through this to make sure that we're all on the same page. We said that compounds, for example, that elements were only just one type of atom. They're only one type of substance. So things like silver, right? Silver only had one type of substance. It was just Ag. It's just that certain type of atom. We'll talk more about what atoms are in future videos. So silver would be an example of an element, right? It's just Ag. Similarly, sulfur here, which is S8. So I've got sulfur and silver as elements. There's only one type of atom in that thing, and it's a pure substance. It's not a mixture of multiple types of substances. And then we have for the compounds, right, it's just one substance. You can't filter it, separate it in any way. You can't break it apart in any physical separation method. So that means we're talking about things like table salt and acetone, right, because they have multiple types of atoms in that one substance. So I'll put here acetone, which was C3H6O. And what was the other one? Table salt. Good old salt. Oh, I put table salt, but then I didn't write table salt. Sorry. Table salt's NaCl. CaCO3 is limestone. So NaCl. I may have mentioned this before, but to chemists, the word salt is a lot bigger than it is to most people. Most people, when they say salt, they're talking about table salt, NaCl, but when chemists say salt, we mean any ionic compound that's really highly water soluble. So there's lots of salts out there. And then, like I said before, the last way you can classify matter is mixtures, right? And that's where the composition can vary from one sample to another. It has multiple substances. You can physically separate them. All of those things are true of mixtures, right? Which is true of milk and dirt and air. But what we're going to do here is talk about the different types of mixtures we can have. We can have either homogeneous or heterogeneous mixtures. And so for a homogeneous, I'm actually going to put milk, since we usually get milk that's homogenized milk. For heterogeneous, I'm going to put dirt. And for homogeneous, I'm going to put air. And so how did I know to put those in what places? Let's talk about that. So the difference between homogeneous and heterogeneous. Homogeneous just means that it's basically the same throughout, right? Remember that homo means same. So a homogeneous mixture just means that the substance has the same composition throughout. Or in other words, any sample from that substance is going to be identical to any other sample of that substance. So like with the example, I was mentioning homogenized milk, right? I don't know how much you know about milk, if you've ever been to a farm or you're aware that milk, when it comes out of an animal, if it's a cow or goat or whatever, it has the creaminess that rises to the top, right? There's even a saying, the cream rises to the top. But it separates, the fats separate and float up on top, and then you have the rest of the milk that's on the bottom. That's not homogeneous, that's heterogeneous, because you have one part that's really creamy and one part that's more watery. What we get is, if you go to the grocery store, you get homogenized milk, which means that any sample of that milk has the same composition as any other sample, right? So I'll put here an example would be homogenized milk. Homogenized milk, sorry. Let me write that word a little bit better for you. Homogenized milk. And again, we know this because the first cup of the milk that you pour out of that container is the same as the last cup. It has the same composition as the last cup. I'll say it has the same composition as the last cup. And by composition, I mean it has the same amount of water, percent fat, percent lactose, calcium, protein, all of that sort of stuff that you'd find in milk. It's going to be identical, regardless of if you take a scoop from this part of the milk carton or that part of the milk carton. Now, heterogeneous, right? Hetero means different. That just means that the substance does not have the same composition throughout. So we'll say it does not have the same composition throughout. A good example of that would be something like dirt, right? Dirt, if you have a sample of dirt, the idea is that dirt's going to have things like there's going to be sand particles, there's going to be a little silty particles, but there's probably also going to be small rocks, maybe big rocks. Maybe you're going to find some twigs, let alone bugs and whatever else is in there, right? You can just imagine if you have a big container of dirt, you just go scoop out dirt in your backyard. If I do it and you do it, we are going to get dirt samples that are different. We may have different percentages of rocks. You may get twigs. I don't get twigs. I found a really sandy spot. You didn't find a sandy spot. So that would be an example of a mixture of something, but it's not equal. It's not everything is not equally distributed throughout that sample, right? Dirt is not just like one totally smooth sample or a substance that you can just take a sample out of and all the samples are identical. So I want you to think about these examples here, right? Remember, homogeneous is when every single sample you take is identical, whereas heterogeneous is every sample you take is not going to be identical, and that's within that mixture, within that thing. So I want you to just pause for 1 sec, see if you can figure out if these are homogeneous or heterogeneous examples of mixtures, and then we'll come back and just do this together. All right, so hopefully you paused, took a crack at these. Chicken noodle soup, right? If you take one spoonful, you might get nothing but broth. You take another one, you might get a carrot. You take another one, you might get some noodles. So that would be definitely an example of a heterogeneous, because the compositions of your samples can vary. Now, if you look at something like vinegar, vinegar is going to be the same throughout the whole thing, right? The first tablespoon of vinegar is the same as the last tablespoon of vinegar in that bottle. So this would be an example of a homogeneous mixture, right? Because you got water and you got acetic acid and you got other things in there, but they're all mixed up evenly, and it's not like the top part of your vinegar is more acidic and the bottom is less acidic or anything. Then we have we have coffee. If you take a look at coffee, right, assuming there's no coffee grounds in it or anything like that, that would also be an example of homogeneous. Right? Everything should be well mixed together. If you put any cream or sugar in there, that's going to be evenly distributed, and your first sip should be like your last sip. Same thing for vanilla ice cream. And I mean just regular vanilla ice cream, not like the kind with the little vanilla beans in it, because that might change things, but just regular vanilla ice cream, right? It's the same throughout. No one's going to be fighting over what scoop, who gets what scoop. It's just vanilla ice cream's vanilla ice cream. All the samples are the same. Versus like something like cookie dough ice cream, right? I don't know about you guys or your families or anything like that, but I definitely have people in my house who will pluck out all the cookie dough pieces. And so some scoops of ice cream don't have any cookie dough in them, and others have lots of cookie dough in them. And you're lucky if you get a lot of cookie dough. So, right, not all of the samples are identical, so this would be heterogeneous. So that's all those terms mean. They're big fancy terms for having an equal distribution of stuff versus not having an equal distribution of stuff. Homogeneous versus heterogeneous. So in our next video, right, we should be talking about now how to separate these things out, right? What are the ways that we can use to separate a mixture into purer or pure substances? Happy studying. Good luck.